So this is 2008, AP problem 2008, E&M3. So sometimes in an AP problem you'll have to use biot to solve for the direction of the direction and magnitude of magnetic field. So in this problem it says the circular loop of wire in figure 1 above has a radius of r and carries a current I, right here. Point P is a distance of r over 2 above the center of the loop. Express algebraic answers to parts A and B in terms of r, I, and fundamental constants. So we're just going to be doing part A because that's the only part that has to do with biot. So for part 1, we have to state the direction of the magnetic field B1, they're calling it, at point P due to the current of the loop. So we know that there's two parts to biot. First, we have to find the direction of the contribution of the magnetic field at point P, and then we can find the magnitude of it. So we're just going to do that first part now. So in order to do that, we're going to just take a section. We know with biot we have to take a section of the wire that we're given, and because we're taking a little DL value. So we're just going to do that, and I'm going to take this spot here and just call that this DL. It's going in the direction like into the page. So using that and using the right hand rule, and then we have to find the distance from that DL to the point P. So that's going to be this distance here. I'm going to label that as R. So using the right hand rule, we put our thumb as the direction of DL, which is going to be into the page, and we put our fingers in the direction of R, the distance to point P, and then our palms should face towards the direction of the magnetic field. So that it's going towards the top of the page. So part 1, we're just going to say to the top of the page. So we know that the law of biot says that dB is equal to mu naught I over 4 pi times dl cross r hat over r squared. So we know that the magnitude of r hat is 1, and the cross product means that right here there will be a sine theta. So where theta is the angle between the r and the dl. So this is going to turn into dB equals mu naught I over 4 pi times dl sine theta over r squared. But since theta is just the angle between r and dl is going into the page, and then r is going in this direction up here, we know that they're on different axes. So that means that the angle between them is going to be 90. So sine of 90 is 1. So we're just going to have dB is equal to mu naught I over 4 pi dl over r squared. So now we're going to take a look back at the diagram. So we can see that if we take the dl on this side, say we had like a dl on this side, and we take the r value, and then we see that the dB, so dl is in this direction, and then coming out of the page, and then the r is in this direction, which means that dB is going to be going towards the top of the page in this direction. So that just means that there's symmetry on both sides. So because it's a loop, the dBs are going to be symmetrical, which means that the horizontal cancel of the dBs of the B values cancel out. So only the vertical components, see, because if it's going in the cross direction this way, that means that the horizontal components will cancel out, but then a vertical component will remain. So this is what we're going to call B1, is that value there. So then in order to take into account this vertical, I'm just going to redraw this angle here. So say this is point P. I'm going to say this is going to be, we want this to be B1, this is going to be dB in one direction, dB in another direction, and then that's going to be like r over 2 value. This is going to be an r value from the edge of the loop. Oh, sorry, not like that, yeah. edge of the loop. It's going like this. That's like the loop right there. Ignore this part here. So then we're going to see that there's going to be, in order to take into account this B1, we're going to have to take into account this angle here. We'll call it alpha. So we know that because there's symmetry, this angle will also be alpha. And then we can see that this is going to be our DL, this is going to be our R, that this angle here will also be alpha. So we can turn this into, we can convert this into terms of variables that were given, like R and little r, which we can turn into terms that were given as well. So we know that the sine, we're going to take the sine as alpha, right? So sine of the alpha, which equals, going to equal, this value here is r, and this value here is little r, so opposite over hypotenuse, r over r. And we're going to add that on to the end of this here. So that means we're taking into account that angle there, which means that B1 will just be going in the vertical direction. So then you can say dB is going to equal mu naught I over 4 pi dl r over r cubed, just combining the terms. And then we can say that, well, then we're going to want to figure out what is this little r value, because it's not in any in terms of any of the fundamental constants or in terms of big R or I, so we're just going to find out what it is. So given this, we can use the Pythagorean theorem to find out what this little r is going to be. We know that this is r, which means this also has to be r, the radius, right? So we can say r is going to be equal to the square root of r squared plus r over 2 squared, which is going to be equal to r squared plus r squared over 4, which can be equal to the square root of r squared 5r squared over 4. If this were just turned to 4r squared over 4, and then combine like terms. So then we can simplify and say this is going to be equal to, we can pull out this r root 5 fourths, which is equal to r root 5 over 4. Big R root 5 over 4 is equal to r. Okay, so now that we found this r value, we can then go back to the equation. The dB equals what we found, mu naught I over 4 pi dl r over r cubed. And then we can plug in r. So we're going to say dB is equal to mu naught I over 4 pi dl over r root 5 over 4 cubed. And then we're going to integrate both sides. So then we can find this B1 value. Then B1 is going to be equal to the integral, and we're going to take it from 0 to 2 pi r, because then in big R, so then in that case we're taking into account the whole circumference of this loop of wire, because the DLs are going to be going from, the DLs are going to be going around this whole circumference, so that's how we're going to take it into account. So mu naught I over 4 pi dl over r root 5 over 4 cubed, and then pull out constants. Let's see. Times Okay, just got a new marker because that one was dying on me. So we're going to say B1 is equal to mu naught I times 2 pi r all over Oh, I messed up. I forgot to add this times r, because it's supposed to be times r over r, r over r, so I just forgot to add that there. Times r squared over this 4 pi times r root 5 over 4 cubed. Then simplify further, it's all mathematics, and we end up finding that b1 is going to be equal, after simplifying, to 4 times mu naught I over 5 r root 5. And that will be our answer for b1.